So now let's talk about the z-score and the standard normal distribution. So starting off with what a z-score is. A z-score is just the number of standard deviations away from the mean. So it's a way to measure a certain value in a data set in comparison to the mean. And so let's say I want to find the z-score of some value. If I want to find the number of standard deviations away from the mean, well, I'll have to take that value and subtract from it the mean. So I'll take that value that I'll call x, and I'll subtract from that the mean, which I know I can call mu, and divide that by whatever that standard deviation is, right? Because in my numerator, I have the difference between the value and the mean, and I divide by the standard deviation. Well, this just gives me the number of standard deviations a value is away from the mean. And so what about our standard normal distribution? Well, this is just the name for a certain type of distribution in which the mean is 0. So the mean is 0, and the standard deviation is 1. So if you're told that data is normally distributed, then you can make these assumptions automatically. And so what can we do with this? Well, on the y-axis, we have the probability density. And so what this allows us to do is that if we have a set of data that's normally distributed, then that means I can use these assumptions to convert any given value to a z-score. And if I do that, what this allows me to do is it allows me to find the probability of any given value being less than or greater than a certain value, or even between two values. I can also go the other way around, and I can say that, if I have a value that is greater than 25% of a given population and it's normally distributed, I can find that z-score as well. And so let's just do a few examples. How do I find the area under a curve, under standard normal curve, to the left of z equals 1.5? So if I've got the value z equals 1.5, and I want to find the area to the left of that value, how can I do that? Well, the first method I can use is using that z-table. And using that z-table, I'm just going to look for a positive z-score of 1.5. A positive z-score of 1.5 gives me an area of 0.9332. And on this table of z-scores, we are always talking about this area being the area to the left of any given value. And so this area, and I can call that alpha, is 0.9332. And this checks out because this really gives me the probability that any value is less than that having a z-score of 1.5. And so I know that a total probability goes from 0 to 1. And so this is a valid answer. So if this area is not somewhere between 0 and 1, you went wrong somewhere. Now, what about the other way around? What if I am told, for example, that the area to the right of a given value is equal to, let's see, this area is equal to 0.6520. I've got that area to the right, and I am looking for that z-score. Well, I'm still going to use the table, but now I'm going to look for that area of 0.6520. But there's one problem here. We said that this z-table describes an area to the left of any given z-score. And so how can I find this area to the left of this z-score? Well, I know that the total area under this curve is 1, and so I can find this area by subtracting 0.6520 from 1. And so 1 minus 0.6520 is equal to this area of 0.3480. And so now I can look on my table for an area of 0.3480. And in the realm of positive z-scores, I've got everything greater than 1/2. So let's look at our negative z-scores. And we are looking for 0.3480, 0.3480. And it looks like the closest we're getting is 0.3483. And so I'll estimate that this is negative 0.39. And so that's our z-score. Our z-score is negative 0.39. Now, is there a way to do this with the calculator? Yes. And so if I want to find the area given a z-score, I can go to my calculator and I can go to second VAERS and click on normal CDF. And it automatically gives me a lower value of negative 1E99. And what this means is that the negative 1 with 99 zeros after it. And so this is as close as this calculator is getting to being negative infinity. Because if we look at these two tails, we understand that this is kind of like an asymptote, right? So these tails never quite close. And so we can theoretically have a z-score of negative and positive infinity. And so we're just going to write a very, very, very large negative number to describe this left side, our left bound. And what we're going to do in our calculators, normal CDF does, is it gives us the region of z-scores that we want to find the probability in between. So to the left of z equals 1.5 means we're starting at negative infinity. Our upper bound, going from the left to the right, is going to be 1.5. And because this is a normal distribution, we know our mean is 0, and our standard deviation is 1. Now, if you have a TI-83 calculator, you're going to do the same input second VAERS and then normal CDF, except you're just going to be given an open brackets to put this input. And so you'll put it in the order of left bound, right bound, mean, standard deviation. So it's a little less intuitive in a TI-83. But either way, same inputs, we press enter, and we get this area, 0.9332. Great, that's exactly what we found here. And so now for the situation in which we have an area to the right of a value and we want the z-score. And so for that, we're going to go to second VAERS, and we're going to look for inverse normal. And we're asked for the area. Now, this is automatically going to talk about the area to the left of this z-score, so we'll still have to do that first step to see what the area to the left is. If you have a TI-84CE, you will actually be given the option of an area to the left or to the right. And so the area to the left is 0.3480. I know this is still standard normal. And again, this is what your input will be if you have a TI-83. And I'm given that the z-score is negative 0.39. And that is our brief summary of z-score and the standard normal distribution.